Okay, so now we're going to look at Cauchy's integral formula, and in particular Cauchy's nth derivative formula. Now the integral we're trying to do is exponential of 3 minus z divided by z cubed with respect to z across the contour gamma, and gamma is where modulus of z equals 2. So let's just draw that on here so we can see what we've got going on. That's the reals, that's the imaginaries, and that's the point 2, minus 2i, and 2i. So this is our gamma. Now we can see that this simple closed contour is in the complex plane is fully contained within inside, and we can also say that this region here is contained within this part here. So we can say we have a simple contour, and we can call this radius 3i, so 3. So that's modulus 3. Okay, so now what we need to do is we need to find the singularities of this function. So the singularities of this function is quite easy to see. So singularities are at z equals 0, and you can see it's a pole of order 3. Okay, so now what we do when we use Cauchy's nth derivative formula, so we use Cauchy's nth derivative formula. So what we say is that this integral here across gamma, exponential of 3 minus z over z cubed dz, that equals 2 pi I, and then we divide it by 1 less than the order of this factorial, so we divide it by 2 factorial, and then we multiply by this function here. So let's say, let's just let f of z, let's just write that down right down here, f of z equals exponential 3 minus z. So now what we need to do is take the second derivative, so the second derivative of z, and we take it at the point 0. So here we've got 2 pi I over 2. Now the second derivative of this, so first derivative, exponential of 3 minus z, just write that in, the input doesn't change. But now by the chain rule, we need the integral of the derivative of minus z, which gives us minus 1. Now we've got to take the second derivative of this point z. So we've got minus exponential 3 minus z. Again, the input doesn't change, but now we take the derivative of minus z, which is minus 1. So now we end up with a positive. So now what we do, the second derivative at 0, 3 minus 0 is just 3. So times exponential of 3. So that will equal, that one can cancel out, e to the 3 pi I. And that will give us our answer using Cauchy's nth derivative formula. Okay.